In this video we're going to be looking at continuous uniform distribution, also known as rectangular distribution. The video is going to cover sketching these types of distributions, finding probabilities from them, and also finding unknown values, normally called k. Now, uniform distribution is a rectangular shaped probability density function, and it is given by the function 1 over b minus a, where x is between a and b. So what it looks like is something like this. It's between a and b, and the height of it is 1 over b minus a, and so it's a straight line between those 2 points, and it's 0 otherwise, so just drawing those platforms to show that. So this is a basic generalization of what all the continuous uniform distributions will look like and how they are given. Now let's move on to sketching a couple of uniform distributions. We can see that this is the way that it's written, so x has a uniform distribution between 2 and 6. So if we start by sketching this, drawing my axes, I'm going to mark in the 2, mark in the 6, and it's at some height, we don't know that yet, between 2 and 6, but in our generalization it was 1 over b minus a. So 6 is b, 2 is a, b minus a gives us 4, so the height is 1 over 4. Now why does that work? Well, the area under this curve should be 1. So we know that this length between 2 and 6 is 4, and so if the length is 4, the height of our rectangle to give an area of 1 must be a quarter. Let's look at that with the second example. It goes from minus 3 up to 7 at some height. So the distance between these 2 points is 10. So the height of the rectangle must be 1/10 in order for the area under the curve to be 1. And again, if we did b take away a, so 7 take away minus 3, we would get 10. So the height of this one is 1 over 10. So now let's move on to how we can find probabilities from a continuous uniform distribution. So I've pre-sketched the 2 graphs that we saw before, and we're going to look at these 2 questions for both of the graphs. For the first one, we've got the probability that x is less than 3. So if I draw in where 3 is on this PDF here, we want to find this area here. This is that area is the probability that x is less than 3. So what we know is that this is a rectangle that's been formed with a length of 1 between 2 and 3 and a height of a quarter. So our probability for A is going to be 1, which is the length, times the height, which is a quarter, which is a quarter. Now if we move on to the second question, we've got 3.5 up to 5.4, so that's this area here. And so again we have a rectangle. Length there is 1.9 and the height is still 1 over 4. So our calculation is going to be finding the area of that rectangle, 1.9 times a quarter, and that gives us an answer of 0.475. Now moving on to the second question, or the second graph. Again looking at part A now, where the probability of x being less than 3, if I draw in 3 on our graph, we've got to find all of this area here. Again, it's a rectangle, we're always working with rectangles on these ones. The distance between those 2 points is 6. The height of this graph, as we worked out before, is a tenth, so we need to do 6 times a tenth, which is 0.6. And then for part B, we're going between 3.5 and 5.4, so that area there. That distance between those two is 1.9. Multiply that by the height of the rectangle, which is a tenth, which gives us a probability of 0.19. So now moving on from that, we're going to look at the third type of question that comes up, where you're asked to find k. So you'll be given the function, but it'll be between some limits. We've got to find what k is. So let's start by sketching it in. We know that it's got a height of a third, and it's between k and 5. So how can we find out what k is in this instance? Well, we know that the area under the entirety of the curve is 1. So we know that this length plus this length equals 1. This first length here that I've drawn, this length here, is going to be 5, take away k. So if we do 5, take away k, and we multiply that by the height, which is a third, that will give us the area of the entire rectangle, which is 1. Now manipulating the equation, multiplying through by 3, we get 5 minus k equals 3. We'll end up with k is 5 minus 3, so k equals 2 in this question. We now move on to the second one, slightly more challenging. Again, let's draw the PDF. We know that it has a height of 1/7, and it's between k and 3k minus 5. So again, we're dealing with a rectangle. We've got to work out this length multiplied by this length, and that equals to 1. So the length here in terms of k is going to be 3k minus 5, take away k. So 3k minus 5, take away k. That's our first length, and we're going to multiply that by a 7th. And that will give us the entire area under the curve, which is 1. So again, manipulating this equation, multiplying through by 7, we've got 3k minus 5 minus k is equal to 7. If we collect the like terms on the left hand side, we're going to get 2k minus 5 equals 7. So 2k is 7 plus 5. So 2k is 12. K is 12 over 2, which means that k is 6. So when finding k in these types of questions, we're using the fact that the shape is a rectangle. That's all we're using, and we're using the idea that the area underneath the curve, underneath the entire curve, is equal to 1. So using those two facts, the area of a rectangle formula and the fact that the area under a PDF is equal to 1.